All right, here we go into our final section of chapter 10. So we're looking at permutations, and we'll be looking at combinations in the next video, in the final video. So just a couple things to go through with you on this one. Couple things as we look at the difference between permutations and combinations. These all have to do with how many ways you can do something. The difference will be this is when order matters, and this is when order does not matter, is a combination. So permutations, if you think of things like your phone number, right? The numbers in your phone number can't go in any random order. They have to go in a specific order, right? And so that would, like, your phone number would be a permutation. If you were to look at maybe like a batting order for a baseball team, who bats first, who bats second, who bats third, there's an order to that, and so that would be a permutation. If we talked about people running a race, and so they were placing first, second, third place, that's an order to that. So anything that would describe any type of an order or a difference in value, like a difference in ranking. So if you were to talk about, say, president, vice president, secretary, so on and so on, there is a ranking in that, and so that would make that a permutation. So the basic layout that you're going to see for a permutation looks like this. NPR. So the N stands for how many total items you're working with, and the R is how many of those items are you actually going to put in order. So this value always has to be equal to or smaller than this one. This has to be the bigger value because, again, this represents the total possible you have to choose from, and then this is how many of those you're actually choosing. So if we were to say something like I have 11 players on my baseball team, and I need to pick a batting order for tomorrow's game, but in a batting order you can only have 9 players. So even though there's 11 players on my roster, I'm only going to pick 9 of those to put in order. So it looks something like this. So this is something you can do in your calculator, but let me show you first what this means. I have 11 people to choose from, and I'm basically going to count down till I have 9 total people. So there was 11 players that I had to choose from for who bats first. Then there's 10 players left to choose from for who bats second. Then there's 9 players left to choose from for who bats third, who bats fourth, fifth, sixth, seventh, eighth, and ninth. So if I multiply all those numbers together, that's how many different batting orders you can come up with for just 11 people and putting all 9 of them in order. So obviously you don't want to type into your calculator 11 times 10 times 9 times 8. That would take you a long time. So instead, you probably have a button that actually looks like this. It's just maybe a matter of finding it. Sometimes they're on the very front of your calculator. Sometimes they're not, and you might have to go into like a probability button like this one. But if you can find that one, so if I hit probability on this calculator, this is what comes up for me. So I have my permutation, my combination, and then I'm going to show you factorials in just a second. That's going to be our next item here. So in order to do this on the calculator, my calculator wants to know what my N value is first. So in my home screen, I'm actually going to type in the 11 first, and then I'm going to hit probability. I'm going to hit enter, and now I can type in the second number, which is 9, and I'm going to hit enter. Big giant number, right? So that's actually how many different batting orders you can create with 11 people. So obviously that can go up if you had more people. So a lot of values in cases like this. Keep in mind that, again, I said this is the number you're starting with, and this is how many places you're going to be counting down. So I started with the 11, and I counted down until I had 9 total places, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So you could do that with any number. Here's maybe a smaller example. So what if we said 6p3. Or I'm going to keep it even simpler, 6p2. Right? So again, this means I'm going to start with a 6, and I'm going to count down until I have 2 total places. So my next number down would be a 5, and I'm going to stop right there because I have 2 numbers. I started with a 6, and I counted down until I had 2 numbers. Obviously, a case like this, I wouldn't need a calculator for. So some of the smaller items like this, maybe you could even do by hand without your calculator. A factorial is when this number is equal to this number. So let me go back to this one that I just did. So if I had 6 items to choose from, and I was actually going to put in order all 6 of those, so 6, 5, 4, 3, 2, 1. Oops. I'm looking at this and I'm saying 1 out loud. It should have been a 1. Okay, so if you have 6 items and you're actually going to place all 6 of them, that means you're starting with a 6 and you're just going to count down to 1. That's called a factorial. So instead of writing it this way, you could actually write it this way. So these two things mean the same thing, right? Again, this just tells you you're starting with a 6 and you're counting down to 1. If I said, I don't know, 4 factorial, that would, again, just means 4 times 3 times 2 times 1. And that would mean the same thing as if I did this. So we could write it either way. So I could do 4p4. So I'm going to do 4p4. And so my answer is 24. Well, also watch, if I do, so I'm going to clear that. I should also get 24 when I do it this way. So I'm going to clear that. I'm going to hit 4, probability, and I'm going to go over to the factorial and hit enter. Enter, also 24. Right? So these are the same things. So you could do it either way. That's one, although you could probably even do that one without a calculator. But so that's what we're going to be looking at today. Let me jump over to 2 pages farther. So let's go to 307. And we're going to go through a couple examples here. Okay, so when you're doing word problems, you want to look for certain keywords like this. Right? Anything that tells you you're putting them in a certain order matters, it now becomes a permutation. If order doesn't matter, then it's a combination. We'll do that in the next video. So in this one, it says find the number of ways I could arrange all of the numbers. So if you look at these, how many ways could I arrange all of the numbers? Well, how many numbers are there? 1, 2, 3, 4, 5, 6, 7. So there's 7 numbers, and I'm going to arrange all of them. So there's 7 numbers, and I'm going to place in order all 7 of them. Keep in mind, if you are doing all of the numbers, then it's also a factorial. So I could also write it this way. Right? That would mean the same thing. And the rest is calculator. And I know you can do the calculator stuff, so I'm just going to show you how this would go into a calculator. So that would be part A. Part B is, what if I, instead of arranging all of them, what if I'm only going to arrange 3 of the numbers? So again, I have 7 numbers to choose from, but I'm only going to arrange 3 of them. Right? So now it's no longer a factorial. I can't write it this way. I'd have to write it this way. But I could do this in a calculator. Right? Remember what this means. I'm starting with 7 and I'm counting down until I have 3 total places. So 7, 6, 5. So I could type it in this way, or I could type it into my calculator this way. Right, whatever is easiest for you. Jump over to this one. What do we got on part 2 here? So this is actually all 10 numbers, right, on that one. And so, again, it's either, if I'm going to arrange all 10 of them, it's 10p10 or 10 factorial. Same thing. If I was only going to arrange 3 of them, well, I still have 10 numbers, but I'm only going to arrange 3 of those. Right? And so again, you could do this in a calculator. Let me jump down to number 3 here. So I have a rock band. I got 9 songs. but I only want to put 5 of them on my demo CD. How many possible ways could 5 be ordered? That's our keyword. We're putting them in order. Plus 2, you kind of have to think of like, if I'm actually putting songs on a CD, naturally they would go in an order. There has to be a first song, a second song, a third song, and so on. So anyway, because I'm putting them in order, I know it's a permutation. Remember, the number that goes here is how many total you have to choose from. We had 9 songs to choose from. Of those 9, how many are you actually putting in order? Right? We're going to put 5 of them in order. So 9p5. And the rest of that could go in your calculator. Let me give you 2 last ones here real quick. So number 4. So witness, blah, blah, blah. License plate. Find the probability license plate starts with a T and ends with an R. So on this one is a little tricky because it doesn't quite fit this natural permutation setup, because it's giving us some specifics here, right? I already know it starts with a T and I already know that it ends with an R, so I'm kind of limited as to what I can do with all these as far as the order goes. So when it comes to problems like this, it's probably best to just sort of lay out the options here. So there's 1, 2, 3, 4, 5, 6 letters, 6 places on this license plate. So 1, 2, 3, 4, 5, 6. How many of those letters can go into the first spot? Right? Only one of them, because they said it starts with a T. So there's only one option for the first letter. What about, so let's cross him out. He's already been used. When you get to this one, actually I'm going to do this one first before I even identify this guy. It must end with an R. Okay, so there's only one option for that slot, right? It has to end with an R. There's only one way to do that. So how many do I have left? So I got 1, 2, 3, 4 letters left. So how many options do I have for this one? Well, any of those 4 could go here. Once I put one there, how many do I have left for this spot? Well, 3 of them could go here. Once I choose this one, how many do I have left for that spot? There's only 2 letters left. Once I choose this one, there's only 1 more letter left for that spot right there. So all you'd have to do to see how many ways you could put this stuff in order according to that description is just multiply those numbers together to get that answer. And that would be it. Let me show you one last one that I wrote just to give you an idea of how this works in probability. So if I had 12 floats in a parade, so there's 12 total ways I could put these things in order. And the order of the floats is chosen at random. Okay, and so, but again, there's an order to this. There's one that's first, there's one that's second, third, fourth. So whenever we look at probability, remember the denominator is what it is the total possible that you have to choose from. This is your sample space. Okay, and so if I had 12 floats and I'm going to put all 12 of them in an order, we know that it now is 12 factorial or 12p12, same thing, right? So that's my total possible to choose from. The numerator is always how many ways can you get what you want. So if we said, what's the probability that your float is first and the school chorus is second, well, how many ways could we then order all of the floats? Well, if I want mine to be first, there's only one way that can happen. And if I want the school chorus to be second, there's only one way that can happen. But now I have, for the third slot, there are now 10 remaining floats that could go into that third slot. And then once I choose one, now there's 9 remaining floats for the fourth spot. Then there would be 8 remaining floats for the next spot, all the way down, right? Until you went down to 1. So if I multiplied all those numbers together, that's what would go on top of my setup. And then I could just do this divided by this in order to get my probability or my decimal, which I could turn into a percent. So that's it for part 1. We'll get to part 2 in the next video.